Lumen point. Let's begin the breakdown.
All right, welcome to The Explainer. Today we are diving deep into one of the most violent, most bizarre, and honestly one of the most important objects in the entire universe. We're talking about the neutron star.
You know, that is the perfect way to describe them. Neutron stars are pretty much the absolute limit of matter as we know it. I mean, you push them just a tiny bit harder and poof, they collapse into a black hole, into nothingness. So what exactly are these things, and where in the cosmos do they even come from?
Well, in a nutshell, a neutron star is what's left behind when a truly massive star dies. Think about this. They're basically giant atomic nuclei, about the size of a city, but they have the mass of an entire star packed inside. Now, to even begin to wrap our heads around how something so strange can exist, we've got to go back to basics. We need to understand what a star is in the first place.
Okay, so picture this constant cosmic battle, right? On one side, you've got gravity. It's relentless, always trying to crush the star, pulling every bit of its mass inward. But fighting back from the inside, deep in the core, you have nuclear fusion. The intense pressure down there is releasing a tremendous amount of energy, always pushing outwards. And for billions of years, these two forces are locked in this perfect but really fragile stalemate. The thing is, that balance, it just can't last forever.
So, what happens when that fuel finally runs out? Well, it really all comes down to size. For medium stars, stars like our own sun, they'll puff up into a red giant and then kind of peacefully fade away, leaving behind a dense little core called a white dwarf. But for the real heavyweights, the stars that are at least 8 times more massive than our sun, oh boy, their end is anything but peaceful.
Yeah, the death of a massive star is seriously one of the most dramatic events in the entire universe. Once it burns through all the hydrogen in its core, it kicks off this frantic, accelerating race against time. It starts fusing heavier and heavier elements, just desperately trying to generate enough energy to fight off the inevitable crushing force of its own gravity.
And you have to see how fast this all happens. It's just insane. What took millions of years with hydrogen gets compressed into a terrifyingly short timeline. Carbon burning? That takes a few centuries. Then neon? For just 1 year. Oxygen? A few months. And then, in the final single terrifying day of the star's life, its entire silicon core gets fused into iron.
And iron is the end of the line. Game over. You just can't get any more energy out of fusing it. It's basically nuclear ash. So the star's fusion engine, the very thing that's been holding gravity at bay for millions of years, it just suddenly and completely shuts off.
And in that split second, gravity wins. The core gets crushed with a force that is just unimaginable. It's so intense that electrons are literally shoved into protons, and they combine to create neutrons. You have an iron core the size of our entire planet that collapses in less than a second into a ball of pure nuclear matter just a few kilometers across. So then, what about the rest of the star? The outer layers, with nothing holding them up, come screaming inwards at a quarter of the speed of light. They slam into this new, impossibly hard neutron core, and they bounce. And that bounce, it creates a shock wave that just rips the rest of the star to shreds. This is a supernova. An explosion so powerful, so mind-bogglingly bright, it can briefly outshine its entire home galaxy. And what's left behind, sitting there in the middle of all that fading cosmic firework? That's our subject, a brand new neutron star.
Okay, so the star is gone, and this new, totally bizarre object has been born. So let's take a little journey inside one and try to really grasp just how extreme this thing is. And I'm telling you, the word dense doesn't even begin to cover it.
Let's just start with a number, okay? 1 billion tons. To give you some perspective, that's like taking every single car on planet Earth and crushing them all down into a little ball. Now imagine taking all that weight
And packing it into a space the size of a single sugar cube. That's right, a sugar cube of neutron star stuff weighs 1 billion tons. 1 billion tons! You could hold it in your hand, well, if it didn't immediately just tear through your hand, through the floor, through the entire planet, and out the other side.
Or, hey, here's another way to think about it. Imagine taking all the rock, all the ice, everything that makes up Mount Everest, and crushing it all down until it fits inside a single cup of coffee. That is the kind of density we're talking about.
And believe me, the weirdness does not stop at density. Their gravity is so strong it literally bends the path of light, so you could actually see parts of the back of the star from the front. The surface temperature, a cool 1 million degrees Celsius.
Oh, and they spin hundreds of times per second. And to top it all off, they have the strongest magnetic fields anywhere in the known universe.
So, let's say we could get closer. What would we even find? Well, the surface, and I'm using that term loosely, is called the crust. It's a solid crystal lattice made of iron nuclei that was left over from the supernova. It is unbelievably hard, but trust me, as we go deeper, things get much, much stranger.
So, you go beneath that crust and you hit the next layer. Here, the pressure is just so immense that the atomic nuclei get squished together so hard they can't stay in their nice little spherical shapes. They merge and form these long strings, like spaghetti, or flat sheets, like lasagna. And yes, physicists, clearly with a sense of humor, actually call this nuclear pasta. It sounds kind of funny, right? But this stuff is thought to be the single strongest material in the entire universe.
Okay, so we've made it through the crust. We've passed through the layer of nuclear pasta. So that brings us to the ultimate question, doesn't it? What's at the very, very center, where the pressure is just absolutely off the charts?
And the completely honest answer is, we have no idea. We just don't know. Our laws of physics, everything we think we know, it just breaks down under these conditions. I mean, it could be that the protons and neutrons themselves literally dissolve into this hot soup of their basic building blocks, quarks and gluons. Or maybe it's something even more bizarre, something we haven't even dreamed of yet. This is truly the absolute frontier of physics.
So, look, all of this it's fascinating, it's bizarre, but you might be sitting there thinking, okay, so what? What do these incredibly weird alien objects have to do with me? Well, it turns out we have a very deep and a very golden connection to them. And to understand it, we have to talk about an even more violent event. You see, sometimes neutron stars aren't born alone. They come in pairs. And over millions of years of orbiting each other, they spiral closer and closer and closer until they finally collide in this cataclysmic explosion that we call a kilonova. And when this happens, it just spews this tidal wave of pure neutron-rich material out into space. And right here, this is the big payoff. Because in the fleeting, incredibly violent moments of that kilonova explosion, all of that neutron-rich stuff decays and reforms into the heaviest elements in the universe. We're talking about the gold in your wedding ring, the platinum in your car, the uranium that powers our cities, all of it. All of it was forged in the fire of two colliding dead stars.
Just think about that for a second. That incredible cosmic cycle. To create these precious elements, a star has to die twice. First, a massive star lives its life and dies in a supernova just to create the neutron star in the first place. And then, that dead star has to die again in a collision with another one just to create the elements that make our world and our lives so rich and complex. So really, the next time you hold a piece of gold jewelry, to stop and remember where it came from. The individual atoms that make it up are born in the heart of a kilonova, maybe billions of years ago. They journeyed across the entire galaxy, got caught up in the cloud of gas and dust that would eventually form our solar system, and now they're here with us. We are, quite literally, connected to the remains of stars that had to die twice. And it really makes you wonder, doesn't it, what other secrets are still hiding in the hearts of these incredible cosmic ghosts?
Fuel your curiosity. Subscribe for the explanation. Stay for the knowledge.